Let's take a look at example 12. When you look at example 12, what's the fundamental rule we need to use? Is it constant multiple rule? Is it addition rule, subtraction rule, product rule, or quotient rule? What do you think for example 12? Good. That's right, Simon, for sure. When I look at this, I see it looks like something over something fundamentally. So that means we got to use the quotient rule. Okay. So let's write this out. So this would be our k prime of x. That's going to be the derivative of the top thing, 2x cubed jx times the bottom thing. So let's put square brackets around this, times the bottom thing, which is 3x plus 5, minus the derivative of the bottom thing. What's the derivative of 3x to the 5th? Are we at the point where we can just look at this and know what the derivative of this guy is? Or no? Is that too soon? Too soon? You guys see it's 3, I hope. This is just a line, right? It's a line with slope 3. It's a line with slope 3, shifted up 5. So at any point, the tangent line to the line will just be the line itself, and that slope will be 3. Or you can use the sum rule. I'm just going to write 3. And then we need to do times the first thing, which is going to be 2x cubed jx, all divided by the bottom squared. The bottom squared is going to be 3x plus 5 squared. Now we're not done yet. We're not done yet because we still have this derivative symbol. What rule do I need to use to find the derivative of this guy? Audrey sees it. Lucine sees it. Okay, this is a product rule, right? Because when you look at this, it's like this is something times something, where one thing is the 2x cubed and the other thing is the j of x. So I kind of need to train you so you could look at a function, a complicated function, and say, oh, this is the fundamental rule. It's a quotient rule. And then when you look inside those square brackets, you see, oh, this is a product rule. Like I need that. I need that vision to happen. That's what I'm trying to train. That's the purpose of these examples. So we're going to use the product rule on this guy. So I'm going to do that jerk thing where I just kind of copy this. And then I'm just going to erase what's inside the square brackets and calculate that. So we need the derivative of the first thing. The derivative is 2x cubed. That derivative is going to be 6x squared, right? And then I got to keep the second thing, which is j of x. I got to take the derivative of the second thing, which is j prime of x. And I keep the first thing, which is 2x cubed. So this right here is your final answer. Okay. Is there any questions about this? No questions. I guess I would say when we do the first part, we're thinking of it as like f divided by g like that. And when we do the second thing, we're looking at it like f of x times g of x like that. And the f's and g's are different. I don't know if that helps reference.